Welcome guys in this lecture, and now we are going to talk about star-delta driving. Star-delta configuration is very important if you have a motor of 5.5 kilowatts or above. If you do, you cannot use the direct motor driving. Because of this high rating, the inrush current is going to be too high that it might burn your contactor. So we divide the startup into two steps. The first step is a star and the second step is a delta. But you might ask, what is a star and what is delta in the first place? The configuration of a star or a delta defines the way that the motor windings or coil are interconnected with each other and with the three-phase power. The way that the windings were connected in the previous lecture until this moment were in delta. The delta configuration draws the maximum current it can draw the moment we connect power to the motor. But with large motors with high ratings, this is not suitable. So let's start illustrating this so that you can understand what's going on. These are the motor internal windings, or you can call them coils. We have three coils like this, and every terminal has a name. So the first coil is U1, U2, second is V1, V2, third W1, W2. Now note that in direct driving, three cables were coming out of the motors and we were connecting them to the contactor. And this is how the delta configuration inside the motor looks like. The motor usually comes wired like that and only three cables are out of it. And I just want you to understand that this configuration gives you the maximum voltage and the maximum current so that the motor can work at full power. Now, to reduce voltage and current, we are going to use the star configuration, which looks like this. And since we are changing the shape of the winding, like at first we're going to connect the motor at star, after some time it's going to configure itself to delta, we are going to extend the 6 wires to our contactors. So we will leave no internal motor connections, but we will take all the connections and change them at the contactor side. The same way we were reversing phases when we wanted to drive the motor backwards and forwards at the contactor side. So two steps, star connection, timer will wait, and then it will configure itself to delta connection. And now we'll see how we can achieve this with three contactors side by side. Now the contactor K1 is always connecting L1 to V1, L2 to U1, and L3 to W1. In both diagrams, delta and star, you can check them on the right hand side. This is a common connection for both. So no matter in which configuration we are, this contactor will always be latching. Now let's connect the first side or the input of K3 or the star contactor. Look at the diagram. U2, V2 and W2 are shorted together. They are connected to the same point. So if we connect all the input of our K3 together, we will achieve the same configuration because all of them are shorted together, the same as a star. So we will take the U2, W2, V2 cables from the motors and connect them directly to that star contactor at its output. So now simply, if we are going to start the motor in the star configuration, we give a start to the K1 contactor, it's going to latch, and by K1 latching, we have connected L1 to U1, L2 to V1, L3 to W1, and at the same time, if we latch K3, we would have shorted U2, V2, W2, the same as the diagram showing of the star contactor. Now let's prepare the delta contactor connection. Take a look at the delta diagram. We have to connect L1 to both V1 and W2. And we have to connect L2 to both V2 and U1. And we have to connect L3 to both U2 and W1. So here we give U1, V1, W1 to the input of the delta contactor, and we give U2, V2, W2 to the output of the contactor in a way that we short circuit V1, W2, V2, U1, and V2, W1. And now notice that if we latch K1 and K2 at the same time, we are going to get the same exact configuration as the delta on the right hand side. Now let's build a control circuit to do this operation. And note that we should never connect delta and the star at the same time, or we will have a short circuit between the phases and the motor will be damaged. Let's see what we have. We have one push button for start, NO type, and we have one push button stop, so it's an NC type. We have K1, K2, and K3 coils of the contactors. Now for the auxiliaries, we only have one NO auxiliary for K1, we have one NC auxiliary for K2, and one K3 NC auxiliary. The K1 NO is used for the start latching. The two NCs, which are K2 NC and K3 NCs, are used to protect the circuit from activating both delta and star contactors at the same time. Now we have a new component here, which is T1, which stands for a timer. The timer here is very important. It's going to automatically switch between star and delta. We will give it a preset time, and when this time elapses, it's going to switch from star. It will shut the star down and connect the delta contactor. So this is switching between the NC and the NO is the method we will use to switch between star and delta. Now let's simulate it and see what's happening. We press the start button, the coil of the first contactor will be energized and the coil of the timer will be energized. The timer will start counting and its NO is still open till the time elapses. The K1 NO is now closed because K1 is energized, hence it will deliver power to K2. And remember here K2 is the star contactor. So we have activated the main contactor and the star contactor to achieve a star configuration in the motor windings. Now we are going to wait for some time, let's say around 30 or 40 seconds, until the timer elapses. This waiting will ensure that the inrush current for the star connection has already passed. And since this is a large motor, the inrush current is going to last longer than the previous motors we were studying. Now notice that since we energized K2, the K2 NC now got open. Hence it's doubling the safety to prevent the delta connection from working. Say if the timer got broke or something, it will start conducting power to K3. So this additional K2 NC here is to ensure that this situation never happens. Now the timer has elapsed, so T1 NC will open, so the K2 right now is going to delatch, and since it delatched, the K2 NC will conduct, and T1 NO will conduct also because the timer has elapsed. And by that conducting power to K3, which is the delta contactor. And now we have K1 and K3 configuring the delta connection. Also notice that since K3 got latched, the K3 NC is open now, so there is no way K2 can operate and there is no way that the star will be working along with the delta at the same time. And now if we press the stop button, everything will delatch and we're back to the off situation.